Look at this fuel. At room temperature, it's not even a liquid. It's black, thick, and sticky, closer to roofing tar than anything you'd ever pour into a car. If you tried to run your engine on it, you wouldn't get to the end of your street. It would clog every line, choke every filter, and kill the motor in minutes. And yet, the largest moving machines humans have ever built, the cruise ships and container vessels that cross entire oceans, run on almost nothing else. Not clean diesel, not gasoline. This stuff. The bottom of the barrel, literally. Most people assume a cruise ship burns some kind of premium marine fuel, something refined, something clean. The opposite is true. These ships are deliberately designed to burn the cheapest, dirtiest, heaviest fuel that exists, and they do it on purpose. There are 3 layers to this story. The first explains why they choose this fuel at all. The second reveals the hidden technology that makes burning tar even possible. And the third is a twist that changed the entire shipping industry almost overnight. By the end of this video, you'll never look at a cruise ship the same way again. So, let's start with the obvious question. If this fuel is so thick, so dirty, so difficult to use, why don't they just run on diesel like everything else? And the answer is exactly what you'd think, and also completely wrong. Most people assume it's about money, and they're partly right. But the real reason goes deeper than price. It starts with where this fuel actually comes from. When crude oil arrives at a refinery, it gets heated and separated into layers. The light stuff rises to the top. That's your gasoline, your jet fuel, your clean diesel, the valuable products. But at the very bottom, after everything useful has been boiled off, there's a heavy, thick residue left behind. For decades, refineries had almost no use for it. It was the leftover, the waste at the end of the process. That leftover is called heavy fuel oil. In the industry, they call it bunker fuel. And because it's essentially the scrap of the refining process, it's dramatically cheaper than diesel. Depending on the market, heavy fuel oil can cost significantly less per ton than the clean marine diesel sitting 1 grade above it, sometimes 30% less, sometimes more. Now here's why that gap matters so much. A large cruise ship doesn't sip fuel, it drinks it. A big vessel can burn anywhere from 150 to 250 tons of fuel every single day at sea. Not gallons, tons. On a long voyage, that's thousands of tons of fuel per trip. So do the math. When you are burning that much fuel, even a small difference in price per ton multiplies into millions of dollars a year. For a shipping company, choosing diesel over heavy fuel oil isn't a minor upgrade. It's the difference between a route that makes money and a route that loses it. But price alone doesn't explain everything. Because if heavy fuel oil were simply impossible to use, no amount of savings would matter. And this is where it gets interesting. Because these ships aren't just tolerating a bad fuel, they're built from the ground up around it. Here's the problem nobody thinks about. Remember, this fuel is basically solid at room temperature. You can't pump tar through a fuel line. You can't spray it into an engine. So how does a ship burn something that won't even flow? The answer is heat, and a lot of it. Deep inside every ship that runs on heavy fuel oil is an entire heating system dedicated to nothing but keeping that fuel warm enough to move. The storage tanks are heated. The fuel lines are heated. And before the fuel ever reaches the engine, it's warmed up in stages. First, it's heated just enough to pump it. Then it's heated far more, often past 130 degrees Celsius, hot enough to thin it into a fine mist that an engine can actually burn. But heating isn't even the hard part, because heavy fuel oil isn't just thick, it's dirty. It's full of contaminants, water, sludge, and tiny particles that would destroy a normal engine. So before that fuel gets burned, it runs through a series of high-speed purifiers. These are centrifuges that spin the fuel thousands of times per minute, flinging out the water and the solids and separating the clean, usable fuel from the garbage. So by the time this fuel actually enters the engine, it has been heated, thinned, spun, cleaned, and heated again. An entire hidden industrial process is happening below deck on every voyage, and the passengers upstairs by the pool have absolutely no idea. And then there's the engine itself. Because you couldn't burn this fuel in a car engine, or a truck engine, or even most generators. But a marine engine isn't like any of those. The engines that power these ships are enormous, slow-turning giants, some of them as tall as a 3-story building, with cylinders you could climb inside. They turn incredibly slowly compared to a car engine, and that slow, massive design is exactly what lets them swallow a fuel this heavy and this dirty without tearing themselves apart. So now you can see the full picture. The fuel is cheap because it's a leftover. The ship is engineered specifically to heat it, clean it, and burn it. And the engine is one of the only machines on Earth tough enough to handle it. Everything fits together. For decades, this was simply how the oceans ran. But here's the part almost nobody expects. That same cheapness came with a hidden cost. And eventually, the world came to collect. Because heavy fuel oil isn't just dirty in a mechanical sense, it's dirty in a chemical one. It's packed with sulfur, far more than diesel or gasoline, and when a ship burns it, that sulfur goes straight up the stack and into the air. For years, the scale of this went almost unnoticed by the public. But the numbers were staggering. A single large ship burning high-sulfur fuel can emit as much sulfur pollution as millions of cars. And there are tens of thousands of these ships crossing the oceans at any given moment. The pollution was invisible out at sea, but it was massive. So regulators finally stepped in. In 2020, a global rule took effect that capped the amount of sulfur allowed in marine fuel, slashing the limit dramatically overnight. And near coastlines, in what are called emission control areas, the rules are even stricter, forcing ships to burn a much cleaner fuel whenever they get close to shore. And this is where the twist comes in. Because the shipping industry didn't simply give up its cheap fuel and switch everything to expensive diesel. Instead, many companies found a workaround that let them keep burning heavy fuel oil anyway. The solution is a device called a scrubber. It's a massive exhaust cleaning system built into the ship's smokestack. As the dirty exhaust rises up, the scrubber sprays it with water, washing out much of the sulfur before it ever reaches the sky. It allows a ship to keep running on the cheap, high-sulfur fuel while still meeting the new limits on what actually comes out the top. So think about what that means. Faced with a choice between switching to a cleaner, more expensive fuel or installing an expensive machine that lets them keep burning the cheap fuel, a huge portion of the industry chose the machine. Because even with the cost of a scrubber, the savings from heavy fuel oil were still worth it. That's how big the price gap really is. And that's the part that surprises people most. The reason cruise ships burn tar isn't laziness, and it isn't an accident. It's a decision made over and over again, at every level, from the fuel to the engine to the regulations to the workaround. Everything about these ships is built to keep burning the cheapest fuel on Earth, and to keep finding new ways to keep burning it. So the next time you see a cruise ship glide out of port, clean and white and gleaming, remember what's actually happening deep below the waterline. There's a tank of black tar being heated toward the boiling point, spun clean, and blasted into an engine the size of a house. The most luxurious vacations on the planet are floating on the dirtiest fuel humans have ever refined. And that's not a flaw in the design. That is the design. So here is my question for you. Now that you know what is really burning under the deck, would you still take the cruise? Drop your answer in the comments, hit like if you learned something, and subscribe for more. See you on the next one.